Professor Bialis here. In this video we're going to be talking about section 3.1, which is going to be introducing the idea of graphing. Now there's a lot of different types of graphing, but we're going to keep it simple and at its most fundamental level. Now what we're going to be graphing on is this right here, which is a Cartesian grid, okay, or rectangular grid if you want to call it that. Basically what it is, you can see that there's two kind of thicker lines here. Those are what we call our axes. Okay, now our axes are simply number line going horizontally and then a number line going vertically. Okay, now again, they are simply number lines. When we were graphing inequalities and we were on a single number line, that is a one-dimensional graph. You can go left or right, that's it. What we're doing here is talking about a two-dimensional graph because you're going to go sideways or up and down. When we deal with three-dimension, which we won't right now, but you'll see it in the future eventually, three-dimension would have another number line coming out directly from the board so that you would have three-dimensional space. Okay, but in this case we're sticking with the two dimensions, and again these are called axes. Okay, more specifically, this is called your x-axis. This is called your y-axis. Okay, all these other lines that are here are just guidelines. Okay, they're grid lines so that we can navigate where we want to be. If I was going to, move over 2 units this way and 3 units this way, I'm going to fall somewhere in the space here. These grid lines simply allow for us to find that exact point, okay, and not just kind of eyeball it in the middle of nowhere. So anyway, let's get back to this. The two main components we're going to be using while we graph are the x and y axis. Where they meet is this point right here called the origin. We call it the origin because that's where everything originates from, okay? After that, when we have that origin there, these lines also break up space, just this white space of the board, into 4 regions. We're going to call those 4 regions quadrants. You have this region here, this region, this region, this region. Okay? And notice those arrows tell you that everything's going out infinitely. We're just looking at a small snapshot here, a small snapshot here. Okay? But everything is expanding out infinitely. Okay, now those quadrants, just so that we can navigate our location, are going to be called 1, 2, 3, and 4. Our first quadrant is in the upper right, and then we go in a counterclockwise fashion. Here's quadrant 2, here's quadrant 3, and here's quadrant 4. Roman numerals are the standard way of labeling those quadrants. Okay, so this is the general layout of what we're going to be graphing on. Now, we will be graphing lines ultimately in this chapter, but lines, as with anything, have to start with points. Okay, so let's talk about points. Now, the points that we're going to be dealing with are going to be denoted with ordered pairs. Okay, now they're ordered because the order that you write the numbers will make a difference, and they're pairs because there's going to be a pair of numbers. There's going to be 2 at a time. Now, those pairs are always going to be listed as x, comma, y. Okay, and the x and y come from the x-axis and the y-axis. So when we're trying to locate ourselves in two-dimensional space, this will tell us the location along the x-axis. This will tell us the location along the y-axis. So let's look at a few examples. Let's call this point A. Okay, we usually use uppercase letters to denote a point. Okay, so point A, let's call it 3, comma 4. Okay, so we have x, comma y, 3, comma 4. That tells us that we are always going to originate at the origin, and we're going to go along the x-axis to 3, so that's 1, 2, 3, and then along the y-axis to 4. So I'm not going to go back to the y-axis. I'm going to start with this 3, and then go up 1, 2, 3, 4 units in that y direction. And then this is going to be point A. Okay? Let's do another one. How about point B? let's say that is -2, 5. Okay, same thing as before. We're going to originate at that origin, but now -2, that's a negative motion to the left. So I'm going to go 2 units to the left, and then 2, 4, 5 units up. And that would be point B. How about point C being -3, -1? Okay. -3, -1, when I start at that origin, I go 3 left, and then down 1, because of that negative on the 1. And that's point C. One more. How about point D being 0, -6? Okay. Now, that 0, -6, the 0 is your x-coordinate. That tells you how to move on your x-axis. Well, if it's 0, I'm not moving at all. So I start at that origin and I stay there. But then I go down 6. I go 2, 4, 6. And that is point D. As you can see, this is a very simple thing to do. However, when I was teaching, back at the high school many years ago, I would sometimes give students a worksheet where they had to plot maybe 30 or 40 points. And if I had a class of 25 students, I would have maybe 2 students get it completely correct. Now, the reason for that is, first of all, some of the points were like 27, 45. So the numbers were getting a little bit bigger, but they were simply miscounting. Okay, so we're not going to be dealing with a 35, 59 or anything like that in these types of applications, not that that doesn't exist, but we're not going to be dealing with that too much here, so you don't have to worry about that, but still, make sure you're counting 4 units, or 5 units, or -3 units. Okay, also, be careful not to switch the x and the y. That's a very easy thing to do if you're not paying attention, or when we get into slope, it's very easy to switch that. So just take your time, pay attention with it, and everything will be fine. Okay? Now, one other thing that I want to kind of build off of these points, going back to these quadrants over here, okay, what I want to generalize are the points that fall within a given quadrant. Okay, so quadrant 1, if I was in this quadrant here, what has to be true about every single point in that quadrant? Well, to get there, I got to go to the right and up. So that would be a positive x movement and a positive y movement. Okay, all points in quadrant 1 would have to be a positive x, positive y. How about quadrant 2? Quadrant 2 would be left and up. So that's a negative and a positive. How about quadrant 3? I have to go left and down. So that would be a negative and a negative. And then quadrant 4, I would go right and down. So that's going to be positive and negative. Okay? Now, why do we care about that? If we can learn some generalities, we don't have to graph anything to know where it's supposed to be. Okay? And when we get into trigonometry later on, not in this course, but in later courses, there's going to be something called a unit circle that has a bunch of ordered pairs that you have to memorize around it. If you know these rules here, you don't have to memorize the points all the way around. You only have to memorize a fourth of them and then just adjust the signs accordingly. So this will get you more acclimated to this grid now, and also in the future will be very useful for other things. Okay, so this is what we're graphing on. This is the general grid, okay, and the parts of the grid, and this is how we are plotting and listing points. Okay, now one more thing about the location of points. If I'm looking at point D, if I asked you what quadrant point D would be in, okay, be very careful with that, because a lot of people say, well, it's in quadrant 3 and 4. And it's not technically, because to be in quadrant 3, you have to have a negative x, negative y. Well, 0 is not negative or positive. Okay, to be in here, that x has to be positive. Well, that's not 0. So if you were asked where that point D is, any point that falls on the axis, you would say it's not in any quadrant and it's on the y-axis. okay, or the x-axis, wherever it falls. Okay, so when they ask you for a location, it's not in a quadrant, it's on an axis. If you want to be very specific, I would say that this D is on the negative y-axis. Okay, so be very careful when you're locating that. After that, let's go into some finding solutions of linear equations. Okay. So, what we're going to be graphing throughout this course, or throughout this chapter, is a linear equation. Okay, so let's first of all determine or lay out what that is. A linear equation is an equation of the form ax plus by equals c. That is what we call the standard form of a linear equation. We're going to talk a lot about linear equations in general when we get into section 5. But right now we're just going to kind of keep it simple. Okay? Now, the other little caveat here with ax plus by equals c is that a, b, and c are real numbers. Now, that doesn't really tell you much, okay? But also, a and b are not both equal to 0, okay? Now, why would we need to state that? If a and b were both 0, both of those terms would be gone, okay? In a linear equation, typically what we're seeing is that we have an x variable and a y variable. Back in chapter 2, we had one or the other, and that was it. But in this case, we're going to be dealing with two. Going back to that theme with the ordered pairs, x coordinate, y coordinate. Okay, so we're going to be dealing with two variables at a time, x and y typically. Okay, but also you could have one of them gone. You can't have both of these gone. Okay, but you can have x and y. What if b is 0? You could just have x. What if x is a is 0? You could just have y. Okay, so you can have just x, you can have just y, or you can have a combo of x and y. That's typically what we're going to see. So this is the type of equation we're going to be dealing with. Let's now talk about checking for solutions. So let me give you a linear equation. Let's say we have 3x minus y equals 12. That's just a regular linear equation, okay? Notice we have the x and the y in there. Now, the question they're going to ask you is 0, 12 a solution to that equation, okay? Now, whenever we were checking answers to equations in the past, what did we do? We simply plugged it in and made sure that that equation balanced out. The exact same thing is going to happen here. Okay? The difference is we have two places that we're going to be plugging numbers into. Now remember, in an ordered pair, it's always x comma y. So all we're doing is plugging in 0 for x, 12 for y. Nothing more than that. Okay? Now remember from the past, when we plug stuff in, reintroduce those blank spots. Put those parentheses in first. And then we go ahead and get our work done. Okay, so here, 3 times 0 is 0, minus 12 is negative 12. Now, the other side doesn't do anything, it just stays as a 12. Is that true? No, so that is not a solution to the equation. It's as simple as that. Okay, let's look at another one. Same equation. Let's say we have -9 now. Same idea. Reintroduce those blank spots. and then plug in x is 1, y is -9. Okay? Notice I plugged in the -9, but that other negative was already there. Okay? Don't just say, oh, the negative's there, so I'm just going to plug in a 9. You have to plug in on top of what was already originally in the equation. So 3 times 1 is 3, minus a negative is a plus 9. 3 plus 9 is 12, and there's your 12. That's a true statement, therefore yes, this is a solution to that equation. It's as simple as that, okay? Now, here's the thing that I want you to realize with these equations. These equations, these linear equations that we're going to be working with, have an infinite number of solutions. This ordered pair works as a solution, okay? And that is one solution. That pairing of numbers is one solution. But that isn't the only solution that's going to exist. There's literally going to be an infinite number of them, okay? So it's not going to be a question, does 1 work for x? 1 works for x, but with what y? Or -9 works as y, but with what x? So it's the pair of numbers that we're trying to lock down with these equations. Okay, so let's look at it now. Let's say we have this as a linear equation. Y equals 1/3 x minus 1. And I give you a table. And that table is going to have a -3, a 0, and a 0. What they're going to ask you to do after giving you all this is say complete the table. Now when you complete the table, what you're doing is completing ordered pair solutions to this equation. Okay? What I mean by that is, for instance, this right here gives you an ordered pair solution, -3 comma, I don't know what yet. Over here, we have an ordered pair solution, 0 comma, I don't know what yet. And this last one is something, comma 0. It's not a question if -3 will work for x. What we need to find is what y, when paired with that -3, works for a solution. So let's calculate that out. So if I know that the x is -3, that can get plugged in. Okay? Standalone, this equation we can't really do much with because we have 2 unknowns. Okay, but watch what happens after I plug in that x. Now there's only one unknown, that y, that we can solve for. So those 3's cancel out, but remember it was a -1. So 1 times -1 is -1. -1 minus 1 is -2. So that is one ordered pair solution to that equation. Okay, let's go to this next one. I've got y equals 1/3 times 0 minus 1. 1/3 times 0 is 0. Minus 1 is -1. So when 0 is x, -1 is going to have to be the y. Last one. Now be careful here because this is a little different. This one they gave you the y value. So I have a 0 for y, and now I have that equation to solve. Okay? What I'm going to do first is I'm going to add a 1. So I have 1 equals 1/3 x. To get the x completely alone, I'm going to multiply everything by 3. And I've got x equals 3. And there we go. What we just found were 3 ordered pair solutions to this equation. How many are there? An infinite number. We just happen to find 3 of them. Okay? That's all there is to it. In this section, they will be giving you the x coordinates and y coordinates and a mixture thereof. Okay? In the next section, we're going to have to figure out our own x and y coordinates. When that time comes, I'll show you how to kind of be a little bit strategic with that so that we can get nicer answers as we go along. Okay? After that, that's pretty much it for this section. Okay? So again, this is a lot of plug and chug. This was introducing this graph grid here where we have x-axis, y-axis. Okay? And then the idea of getting a solution to a linear equation. What we're going to do in the next section is take those solutions and draw a graph. Nothing more to it than that. Okay, so as always, work hard. Let me know if you have any questions, and I'll see you next time.